Welcome to the History Maps podcast. Try to build a 146-meter tall structure today. You have, steel girders, diesel-powered cranes, hydraulic lifts, laser levels.
Right, a whole modern arsenal of tools.
Exactly. Now strip all of that away. Take away the steel, take away the iron entirely, take away the pulleys.
It's hard to even picture.
It is. Remove the very concept of the wheel. You are left with mud, copper chisels, quartz sand, and human muscle. And yet, with just those, rudimentary elements, you are tasked with building a structure so massive, so geometrically precise, that it remains the tallest artificial structure on Earth for nearly 4 millennia.
It is a massive undertaking. Today, we are undertaking a highly detailed analysis of ancient Egyptian architecture. We will be tracking the physical evolution of this civilization from the pre-dynastic period, which is roughly 6000 BCE, all the way down to the Ptolemaic era, ending in 30 BCE.
Right, and we are examining a civilization that utilized architecture as a profound tool of communication and control.
Yeah, they didn't merely build structures just to, house populations or store grain. They translated their entire cosmology, their highly rigid political hierarchies, and their deeply held beliefs regarding eternity into literal physical structures of stone and mud.
So for you, the listener, the objective here is to understand the precise mechanics of exactly how and why these structures were built. We're going to analyze the engineering logistics, examine the highly specific material science behind their choices, track that evolution from, flat tombs to towering pyramids.
And we'll investigate the psychological function of their monumental temples, too.
What?
Because we are really looking at a society's worldview rendered in three-dimensional space.
Absolutely. So to accurately assess this architecture, we really have to begin with the environmental realities of the Nile Valley, right?
Yes. The geography essentially dictated every single aspect of construction. Because there was a severe scarcity of structural timber in the region, builders were forced to rely on a strict dichotomy of material.
And that choice was rigidly based on function.
Completely absolute. Mud brick was utilized for the realm of the living. So palaces, administrative centers, domestic homes, military fortresses, massive enclosure walls.
These were all just built of earth.
Right, earth.
Yeah.
Stone, conversely, was reserved strictly for the eternal realm. So tombs and temples.
Let's start by examining mud brick, since it was the foundational material of domestic and civic life. The term we use today, adobe, actually traces its linguistic roots directly back to the ancient Egyptian word for brick.
Yeah, which was recorded as DBT. And over centuries, this evolved into the Coptic tube, then the Arabic tube, and eventually the Spanish term adobe.
That's fascinating. Now, the recipe for these bricks was not uniform everywhere, right? It was highly localized depending on the specific stretch of the river you were on.
Exactly. Builders extracted the mud directly from the damp banks of the Nile. This raw material was a mixture of Nile silt sand and clay. But the structurally crucial element was the addition of chopped straw or animal dung.
Right, and the straw functioned as a temper, like a vital binding agent.
It did. The manufacturing of a mud brick is actually a really delicate exercise in material balancing. You require coarse sand to provide internal structural strength. You need fine sand to lock that coarse sand into place within the matrix.
And the silt and clay act as a plastic medium and a binder.
Right. The inclusion of chopped straw is what prevents the brick from rapidly shrinking and cracking as it dries under that intense North African sun.
So we can think of the straw operating sort of like the steel rebar placed inside modern concrete. Without that internal tensile support, the sun simply bakes the mud until it shatters into fragments.
That's a perfect way to look at it. But the sources indicate there were necessary variations depending on the exact clay content of the local soil.
Right, because if the earth mixture extracted from the riverbank had a naturally high percentage of clay, builders sometimes just omitted the straw entirely.
Yes, and omitting the organic material reduced the risk of insects, burrowing through the bricks and compromising the structural integrity of the wall over time.
Okay, that makes sense.
But a mud brick with a high clay content, while it is slightly more water-resistant, is actually structurally weaker overall under a heavy load. Conversely, a brick containing a high amount of aggregate sand and straw is exceptionally strong when dry.
But it crumbles almost immediately if exposed to standing water, right?
Exactly. It just dissolves.
And the manufacturing process itself demanded significant logistical foresight. I mean, the workers needed the chopped straw into the damp earth mixture by hand, or frequently just by treading on it in large, shallow pits with their feet.
Yeah, and following this initial mixing, they left the mud to ferment for a night or two. The following day, they rekneaded the mixture, added specific quantities of water to reach the correct plasticity, and then commenced the molding phase.
They utilize a single wooden rectangular mold for this. One end of the long side of this wooden frame was often extended, just to provide a handle for the brickmaker.
Right, so the worker would press the wet mixture firmly into the mold, ensuring the corners were completely filled, then lift the wooden frame away, leaving the wet brick on the ground. The brick was then left to dry in the hot sun.
And for major state-sponsored construction projects, this required immense scheduling. Bricks intended for a construction season in the fall were regularly manufactured in the spring and left to dry, harden, and cure throughout the entire summer.
Because mud brick inherently dissolves when exposed to heavy moisture, as we mentioned, these structures were acutely vulnerable to the annual Nile floods.
Right, which explains why we have so few intact palaces or urban residential zones today, especially when you compare them to the sprawling stone temples. If you have a wall made entirely of river mud, how do you even prevent it from dissolving when the water table rises?
Well, they engineered specific defensive layers. Builders attempted to mitigate this rapid decay by placing the mud brick superstructures on elevated foundations of stone, or sometimes dense sand or compacted gravel.
Okay, so that foundation broke the capillary action that would otherwise draw ground moisture upward into the mud walls.
Exactly. Furthermore, they coated the exterior walls with thick layers of mud plaster. This provided a sacrificial layer against wind erosion and occasional rain.
That structural vulnerability is exactly why stone became the absolute standard for anything designed to last for eternity. When the state mobilized to construct monuments, limestone was the primary choice.
Yes, specifically the fine-grained white limestone, which was highly prized for its smooth texture. It was used extensively for outer casing stones and was quarried at a site called Tura, which is located approximately 15 kilometers south of modern Cairo.
But for heavier, highly stressed, load-bearing elements, the architects turned to sandstone and granite. Sandstone handles horizontal stress better than limestone. It was quarried extensively at Gebel El Sisila, located on the river between Luxor and Aswan.
But the red granite, which was renowned for its extreme density and hardness, was sourced exclusively from Aswan in the far southern reaches of Egypt.
The logistics of utilizing that Aswan granite are just highly demanding. I mean, it was utilized for heavy-duty architectural components. We are talking about massive door jambs, monolithic obelisks, colossal column bases.
Getting that stone to construction sites like the Giza Plateau or the temples of Thebes meant transporting these massive blocks over 800 kilometers down the Nile.
Right, and they managed this by floating the blocks on specialized heavy transport barges during the annual inundation season.
Yeah, when the river was at its absolute highest volume, they could maximize transport efficiency and bring the barges much closer to the construction sites on the desert edge.
But the extraction and shaping of these stones require a close examination of the tools available to the builders. The historical and archaeological records detail the tools these workers had at their disposal.
Right. They utilized wooden adzes, wooden mallets, and copper chisels. They did not have iron. They did not have steel.
Wait, let's unpack this. If you are examining a block of Aswan granite, you are looking at a rock so hard that modern builders use diamond-tipped saws to cut it for countertops.
Yeah, it's incredibly dense.
And copper is a notoriously soft, highly malleable metal. If you strike a block of solid granite with a pure copper chisel, the copper will simply bend and blunt immediately. How could they possibly cut through solid limestone, let alone Aswan granite, utilizing copper saws and drills?
Well, the mechanics of their method rely on an abrasive intermediary. The copper itself was not actually performing the cutting action. The copper was merely the vehicle applying the pressure.
Oh, I see.
The actual cutting agent was loose quartz sand.
So they were essentially grinding their way through the rock via continuous friction.
Precisely. When utilizing a large flat copper saw to cut a block, or a tubular copper coring drill to hollow out a stone vessel, the workers would pour a continuous slurry of water and loose quartz sand into the cut.
Okay.
The soft copper blade would grip the hard, abrasive quartz crystals. As the workers pulled the saw back and forth, the friction of those quartz crystals grinding against the limestone or granite is what actually abraded the stone away.
The copper tool wore down significantly in the process, obviously, and required constant recasting and sharpening, But the sand did the cutting.
Yeah. And for extracting the massive rough blocks directly from the bedrock at the quarries, they employed a different physical method entirely. The sources describe the widespread use of dolerite balls.
Dolerite is an extremely hard, dense, igneous rock.
Right. Workers would take heavy spheres of dolerite and repeatedly pound the bedrock to slowly pulverize a trench, eventually isolating a block on three sides.
And then to separate the block from the bottom bedrock, they exploited the natural properties of the stone and wood. They would carve small slots along the natural geological veins of the rock.
They would then drive dry wooden wedges deep into these cracks. Finally, they would soak those wooden wedges with copious amounts of water.
Right, and as the wood absorbed the water, it swelled significantly. The resulting expansive pressure was immense, sufficient to fracture the stone in a clean line along the vein.
It's remarkably clever. Once a 2-ton block of stone was successfully extracted, we must evaluate the labor force required to move it from the quarry onto a barge and drag it up to a construction site.
Right, and there is a deeply persistent popular misconception here that these monumental structures were built by enslaved populations forced into labor.
The archaeological data, the administrative papyri, and the historical evidence firmly refute that narrative.
Entirely. The labor was organized through a state-run system known as corvée. This is a system of conscripted labor, but it was highly regulated and tied directly to the agricultural cycle.
Yes. During the annual Nile inundation, the river breached its banks and flooded the agricultural fields. Farming became entirely impossible for a period of several months.
So during this specific window, the state drafted tens of thousands of able-bodied peasants to provide seasonal labor on royal construction projects.
It was a highly organized, heavily bureaucratic workforce. The workforce for major projects like a pyramid would peak at 20,000 to 30,000 individuals.
If you are a farmer drafted into the system, you do not just show up and start pulling a rope. You are integrated into a specific unit. These units were called files, and they were often given distinct names, frequently incorporating the name of the pharaoh they were serving.
Right, and these files were then further subdivided into smaller, highly specialized teams of 10 to 20 men.
The logistics of maintaining a workforce of 30,000 people in a centralized location are, frankly, as complex as the architecture itself.
Yeah, these laborers were supported by a massive state-funded infrastructure. Archaeologists have excavated purpose-built worker villages near the Giza Plateau.
These sites contain extensive bakeries capable of producing thousands of loaves of bread daily, massive breweries, facilities for processing fish and cattle to ensure sufficient protein intake for heavy manual labor.
And they even had specialized workshops for constantly resharpening the rapid-wearing copper tools.
There is also clear evidence of medical care at these sites. Skeletons recovered from the workers' cemeteries show successfully set broken bones and amputations that healed completely.
Which indicates that if a worker was injured on the site, they received medical treatment and were allowed to recover.
So, understanding these monumental realities, the material limitations of mud brick and stone, the mechanical reality of copper and sand, and the massive logistical organization of the corvée labor force, that all provides the necessary foundation for analyzing the earliest architectural experiments.
Right. Before the state apparatus could engineer a geometric mountain of stone, they had to establish the basic architectural vocabulary of the tomb.
And the evolution of the Egyptian tomb begins long before the centralized dynastic period. In the pre-dynastic era, roughly 4,500 to 3,500 BCE, we find the earliest precursors to sacred architecture at sites like Nabta Playa, located deep in the western desert.
Here, archaeological excavations have uncovered megalithic stone alignments and complex stone circles.
These structures likely functioned as proto-temples utilized by nomadic groups for seasonal rituals and precise astronomical observation, marking the solstices and the arrival of the monsoon rains.
As these populations gradually migrated and consolidated into permanent agricultural settlements along the Nile Valley, their architecture became substantially more formalized.
We see this at sites like Abydos and Akkada, spanning from 3900 to 3100 BCE. We observe the initial evidence of early urban planning utilizing mud brick construction, but the defining architectural structure for the early elite class was the mastaba.
Yeah, a mastaba is a solid, flat-roofed rectangular structure with outward-sloping sides, constructed almost entirely of mud brick.
The term itself is derived from the Arabic word for bench, because to early explorers, these structures resembled large benches sitting on the flat desert landscape.
Right, and these mud brick superstructures were built directly over deep underground burial chambers.
The development of the mastaba was driven by practical necessity, wasn't it?
Yes, in the earliest pre-dynastic burials, bodies were simply placed in shallow oval pits dug into the desert sand. The hot, arid sand naturally desiccated the bodies, creating early natural mummies.
However, these shallow graves were highly susceptible to being dug up and scavenged by desert jackals.
Exactly. To protect the deceased, the elite began constructing these massive mud brick mastabas over the burial pits.
The profound paradigm shift in this basic architectural design occurs in the Third Dynasty, around 2670 BCE. The pharaoh is Djoser, and he employs a vizier, high priest, and architect named Imhotep.
Imhotep is given the task of building Djoser's tomb at the sprawling necropolis of Saqqara. And the project Imhotep executes permanently alters the trajectory of human engineering.
Right, because Imhotep takes the traditional flat rectangular mud brick mastaba, and he makes a radical decision. He builds it entirely out of quarried limestone.
Which immediately solves the problem of decay and creates a structure meant to last forever. But Imhotep does not stop at a single stone mastaba.
No. Through a process of continuous expansion and revision over Djoser's reign, he stacks successive, smaller mastaba forms, one on top of the other.
The final structure features 6 diminishing tiers of limestone. It reaches a height of roughly 62 meters, utilizing a staggering volume of over 330,000 cubic meters of stone.
We know this structure today as the Step Pyramid of Djoser. This represents an absolute architectural revolution.
Imhotep is credited historically as the first architect to utilize dressed stone on a massive monumental scale.
To achieve a structure of this unprecedented weight and height, he implemented a strict grid system for the layout and utilized detailed architectural blueprints.
The mathematical precision required to stack these immense weights without causing structural failure or lateral blowout. It implies a highly sophisticated, newly developed understanding of load distribution and solid geometry.
I mean, if we evaluate the technological leap Imhotep achieved, it is comparable to a civilization transitioning from building single-story clay houses straight to constructing a modern steel skyscraper.
Absolutely.
And he had to achieve this verticality while simultaneously inventing the required lifting mechanisms, the internal support structures, and the logistics of quarrying stone at scale.
It is a massive leap in both ambition and execution. And the complexity of the step pyramid extends far below the visible tiers.
Right.
The substructure is an elaborate, chaotic labyrinth consisting of over 5.5 kilometers of subterranean tunnels, shafts, and galleries.
The central burial chamber was carved directly into the solid bedrock, 28 meters below ground level. It was sealed with a massive, multi-ton granite plug, a clear indication that deterring tomb robbers was already a primary concern for the architects.
And around this central granite chamber were approximately 400 separate underground rooms.
That's a lot of space.
Yeah, they were designed to hold the vast quantities of physical provisions, furniture, and food required to sustain the pharaoh's spirit in the afterlife.
One specific, highly crucial architectural element introduced at the Step Pyramid complex is the serdab.
This was a completely sealed, small stone chamber situated adjacent to the north face of the pyramid. Inside the serdab was placed a life-size, highly detailed limestone statue of King Djoser.
The chamber was entirely enclosed, except for 2 small eye slits carved directly into the thick stone wall, perfectly aligned with the sightline of the statue's eyes.
This was a highly functional mechanism. The ancient Egyptians believed in a vital life force or spirit called the Ka.
Right, and the Ka required physical sustenance even after death.
The priests would bring offerings of food and incense to the outside of the serdab wall. The eye slits allowed the pharaoh's Ka inhabiting the statue to look out and magically consume the essence of the offerings presented.
The architecture is actively facilitating a psychological and religious transaction there. Furthermore, the step shape of the pyramid itself was not merely a structural byproduct of stacking mastabas.
No, it became profoundly symbolic. In the Heliopolitan creation mythology, the universe began as a dark, chaotic, watery abyss. The creator god Adam emerged from these waters upon the first solid land, a primordial mound of earth known as the Ben-Ben.
The stepped shape of the pyramid served as a massive physical representation of this Ben-Ben stone. It acted as a monumental solar symbol and a literal celestial stairway.
The architecture was designed to physically protect the body and magically facilitate the pharaoh's soul as it ascended the stone steps to the heavens to join the sun god Ra.
The completion of the step pyramid definitively proved that extreme verticality in solid stone was possible. This realization triggered an aggressive architectural evolution during the subsequent Fourth Dynasty.
Pharaohs sought to refine the stepped terrace design into a pure, smooth-sided geometric form. They wanted a true pyramid.
But this transition was highly experimental, and not without its catastrophic failures. Under the pharaoh Snefru, we observe intense, rapid trial and error.
Snefru ordered the construction of the bent pyramid at the site of Dashur. The architects began building at a steep angle of roughly 54 degrees.
However, partway through construction, the massive, accumulating weight of the stone threatened to collapse the internal burial chambers. The stone was physically cracking under the pressure.
To save the structure from complete collapse, Snefru's architects had to hastily reduce the angle of the upper portion of the pyramid to a much shallower 43 degrees.
This emergency structural adjustment resulted in the distinct bent shape we see today. But Snefru learned from this engineering crisis.
He immediately commissioned a new structure, utilizing the shallower 43-degree angle from the ground up. This became the Red Pyramid, successfully achieving the first true, smooth-sided pyramid in Egyptian history.
This intense period of trial, error, and refinement culminated in the reign of Snefru's successor, Khufu. Under the direction of his vizier and architect Temianu, the state embarked on the construction of the Great Pyramid at Giza.
This is a structure that remained the tallest artificial structure in the world for nearly 4,000 years.
The logistical requirements of Khufu's pyramid are almost difficult to process. The structure required approximately 2 million individually carved stone blocks.
The average weight of these limestone and granite blocks is 2.5 tons.
And the sources calculate that to complete the pyramid within Khufu's estimated 20-year reign, during the peak years of construction, the workforce had to set 5 of these massive blocks into their final position every single minute during a 10-hour workday.
Which brings us to one of the most heavily debated topics in both archaeology and structural engineering. How did they elevate these blocks?
Right, because the ancient Egyptians did not utilize the wheel for heavy transport during the Old Kingdom. They relied entirely on wooden sledges pulled over wet sand.
Therefore, they had to construct ramps to elevate the stones to the final height of 146.5 meters.
The sources detail rigorous mathematical and engineering analyses of the various proposed ramp theories. Let's look at the first widely proposed model, the long ramp theory.
This model suggests a single, straight ramp built against one face of the pyramid. As the pyramid grew taller, the ramp was gradually lengthened and raised to reach the new height.
Wait, we have to look closely at the math regarding this theory.
Yeah, the physics of moving a 2.5-ton block on a wooden sledge dictates a maximum practical gradient.
If the incline is too steep, a team of human laborers simply cannot pull the weight upward regardless of how many men are on the rope.
The engineering analysis in the sources states that the absolute maximum operational gradient for a team of workers to steadily drag a laden sledge is approximately 8%.
That translates to an angle of roughly 4.5 to 6 degrees. So if you apply that 8% gradient to the geometry of the Great Pyramid, the long ramp theory completely falls apart.
It does.
To reach the apex of a 146-meter pyramid at a manageable 8% incline, that single straight ramp has to be over a mile long.
Exactly. The mathematics render the long ramp theory highly implausible for reaching the upper levels. First, there is simply no physical space on the Giza Plateau for a mile-long ramp.
Right. The plateau features a steep drop-off to the north, and the concurrent construction of vast nobility cemeteries to the east and west left no available geographic footprint for such a structure.
Furthermore, if you calculate the volume of material required to build a solid mile-long ramp reaching a height of 146 meters, the volume of the ramp would roughly equal, or potentially surpass, the total volume of the Great Pyramid itself.
The state would be expending the resources to build a second mountain merely to build the first one. And there is absolutely zero archaeological evidence of millions of cubic meters of ramp debris left behind on the plateau.
This logistical dead end led scholars to propose the spiral ramp theory. This model suggests a ramp that wraps entirely around the exterior faces of the pyramid, hugging the structure tightly as it spirals upward.
This theoretically solves the spatial problem, as the ramp utilizes the bulk of the pyramid itself for support and stays entirely within the immediate footprint of the construction site.
But the spiral ramp introduces massive flaws of its own. If you wrap a wide ramp around the outside of a pyramid during construction, you completely obscure the faces and, most importantly, the corners.
The corners are the most critical alignment points of the entire geometric structure.
Right. The architects, surveyors, and engineers had to constantly, obsessively measure the angles of the four faces to ensure they were rising at the exact same incline, so that all four corners would meet perfectly at a single central point at the apex.
If a large mud brick and rubble ramp is covering the edges of the pyramid, making those continuous hyper-precise measurements becomes physically impossible.
Additionally, an external spiral ramp clinging to the side of the pyramid would have to be relatively narrow to avoid collapsing under its own weight.
That narrow width creates a severe logistical bottleneck. You cannot have one team of workers dragging a 2-ton block up the ramp while another team brings an empty sledge back down the same path.
The bidirectional traffic flow would grind to an absolute halt. It completely derails that necessary relentless pace of setting 5 blocks a minute.
So to resolve these seemingly impossible engineering paradoxes, the French architect Jean-Pierre Houdin developed the internal ramp theory, also referred to as the hybrid theory.
This model is strongly supported by the mathematical models detailed in our sources. This theory suggests that the Egyptians utilized a phased, highly adaptable approach, changing their construction methods as the physical geometry of the pyramid changed.
The hybrid theory proposes that for the bottom third of the pyramid building, from the bedrock up to a height of about 43 meters, they did in fact utilize an external straight ramp.
That lower section of the pyramid, because of the wide base, contains the vast majority of the structure's total mass. An external ramp reaching a height of 43 meters at an 8% gradient would only need to be about 537 meters long.
537 meters is a massive structure, but the total volume of this lower ramp would only be roughly 266,000 cubic meters.
That is approximately 10% of the pyramid's total volume. Building an external ramp of this size is entirely manageable and highly efficient for moving bulk material quickly.
So the builders utilized this external ramp to move the massive volume of blocks required for the wide lower base. But then, as the pyramid gets higher, the square footage of each level shrinks rapidly.
The exterior ramp becomes less efficient. According to theory, they stop building the external ramp. They actually begin to dismantle it.
Wait, they dismantle it?
Yeah, they take the smaller limestone blocks from the ramp itself and recycle them to continue building the top 2/3 of the pyramid.
And to elevate those blocks up the remaining height, Houdin proposes they utilized an internal spiral ramp.
This ramp was built directly into the outer edge of the pyramid's masonry, situated just a few meters behind the smooth outer casing stones. It spiraled upward inside the structure at a highly manageable 7% gradient.
This internal placement leaves the outer corners and the exterior faces of the pyramid completely exposed, allowing the surveyors to maintain constant vital measurements of the angles.
But this introduces a new mechanical problem.
Right. If you are dragging a 2.5-ton block of limestone up an enclosed internal tunnel, how do you turn that block 90 degrees when you reach the corner of the pyramid?
Houdin theorizes that the corners of this internal ramp were left completely open to the sky during the construction phase. In these open corner spaces, the workers utilized highly specialized wooden cranes.
The ancient Egyptians were already intimately familiar with the mechanics of the lever and the counterweight. They used a device called a shadouf, which is a counterweighted lever system utilized extensively along the Nile for lifting heavy buckets of water for agricultural irrigation.
The theory posits that they adapted this shadouf principle. They built heavy wooden cranes in the open corners.
Okay, so the block would arrive on a sledge, the workers would attach to the crane, use a counterweight to lift the block slightly, rotate the entire crane 90 degrees, and set the block down perfectly aligned for the next straight leg of the internal tunnel.
It is an incredibly elegant structural solution. Once the top of the pyramid was complete, the workers worked their way back down, filling in those open corner notches with masonry and sealing the internal ramp away forever behind the smooth outer casing stones.
The internal ramp theory successfully solves the mathematics of the gradient, the physical space constraints of the plateau, and the strict surveying requirements of the architects all at once.
The Old Kingdom mastered the architecture of the solid, impenetrable vertical mass. The pyramid was fundamentally a closed system.
It was an elaborate vault designed to protect a single hidden tomb and facilitate the ascent of a single man. But as Egyptian civilization moved into the New Kingdom, spanning from 1550 to 1069 BCE, the political and religious focus shifted dramatically.
The capital moved hundreds of kilometers south to the city of Thebes. To match this shift, the architecture evolved from the massive solitary tomb to the sprawling, horizontally expansive interactive temple.
The New Kingdom represents the absolute zenith of ancient Egyptian temple architecture. These monumental structures were constructed utilizing the post and lintel method.
In this system, you have heavy vertical pillars, the posts supporting massive flat horizontal beams, the lintels. The ancient Egyptians did not utilize load-bearing stone arches in their monumental architecture.
Because stone has low tensile strength, a flat stone lintel will snap under its own weight if it has to span too wide of a gap. Therefore, to support a massive stone roof over a large interior space, you need a vast number of highly concentrated, closely spaced columns to carry the load.
This specific architectural limitation birthed the most defining and visually imposing feature of New Kingdom temples, the hypostyle hall.
A hypostyle hall is essentially a dense forest of stone columns supporting a flat roof. And nowhere is this concept more grandly executed than at the massive temple complexes of Karnak and Luxor in Thebes.
Karnak is the largest religious site in ancient Egypt, covering an area of over 200 acres.
Karnak was not conceived or built by a single visionary architect. Karnak was an accumulative project. It was essentially an architectural turf war carried out over centuries by rulers like Thutmose I, Hatshepsut, and Ramesses II.
Each successive pharaoh aggressively added onto, modified, or sometimes actively dismantled the work of their predecessors to legitimize their own rule and demonstrate their devotion to the god Amun-Re.
Despite this multi-generational construction, the layout of these New Kingdom temples was highly standardized and rigorously axis-oriented. They typically featured a strict linear progression.
A worshiper or priest would move from bright, public, open-air courtyards through increasingly dim, columned halls and finally arrive at the small, pitch-black, exclusive inner sanctuary where the cult statue of the god resided.
The entrance to these complexes was sharply defined by structures known as pylons. Pylons are massive, sloping, trapezoidal stone towers that frame a central gateway. They could reach heights of over 20 meters, dominating the landscape.
Symbolically, the architecture of the pylon represented the hieroglyph for the horizon. The gateway was the juncture between the chaotic, profane outside world and the ordered sacred space within the temple precinct.
Passing through the pylons in the open courtyards, you eventually enter the hypostyle hall. The Great Hypostyle Hall at Karnak, initiated by the pharaoh Seti I and completed by his son Ramesses II, contains 134 massive sandstone columns arranged in 16 dense rows.
The physical scale of this space is difficult to process. The 12 columns forming the central processional aisle are 20 meters high.
That is roughly the height of a 6-story building, composed entirely of stacked stone cylinders.
The architecture here is deeply symbolic, drawing its visual vocabulary directly from the natural environment. The columns in these halls were carved to physically reflect the organic plant life of the Nile Valley.
Right. You observe papyrus bundle columns, with shafts mimicking closely tied reeds and capitals expanding outward like a flowering papyrus umbel.
You observe lotus columns with slender shafts and closed bud capitals. You see palm columns with capitals fanning outward, mimicking palm fronds.
When you step into a hypostyle hall, surrounded by this dense, towering forest of plant-shaped columns, the spatial engineering is highly intentional. It was designed to make the entrant feel as though they were walking into a petrified stone version of the Nile River marshlands.
In Egyptian cosmology, life emerged from a primordial swamp. The hypostyle hall is that primordial swamp of creation, rendered permanently in sandstone.
The ceiling above these columns was painted vividly with stars and flying birds, representing the celestial heavens. The base of the walls featured detailed depictions of marsh plants and aquatic life.
The architects also strictly controlled the lighting to enhance this atmosphere. The taller central columns of the great hypostyle hall allowed for the inclusion of a clerestory.
A clerestory is a raised section of wall above the side aisles containing massive stone growwork windows.
This architectural feature allowed a single, highly controlled shaft of bright sunlight to penetrate the gloom, heavily illuminating the central processional path, while the dense surrounding columns of the side aisles remained in deep, mysterious shadow.
Outside these sprawling halls stood the obelisks. These were monolithic, four-sided shafts carved from solid Aswan granite, tapering upward and capped with a pyramidal top called a pyramidion.
The obelisks were closely associated with the solar cult of Ra. They functioned as solitary sentinels, often placed in symmetrical pairs flanking the temple entrances.
The pyramidion at the top was frequently sheathed in gold or electrum. Due to their height, they were specifically designed to catch the very first rays of the morning sun over the horizon, capturing the divine light and symbolically drawing that energy down into the temple precinct.
Every square inch of these temples, from the towering pylons to the base of the obelisks, was covered in highly detailed carved decoration. And the choice of carving technique by the artisans was highly pragmatic and responsive to the environment.
On the exterior walls of the temple, where the blinding Egyptian sun hit the stone directly, artisans utilized sunk relief. They carved the figures deeply into the surface of the stone.
This technique created harsh, dark shadows inside the carved lines, making the images highly visible and legible in the glaring light.
Conversely, on the interior walls, situated within the dim, heavily shadowed hypostyle halls, they utilized raised relief. The artisans painstakingly carved away the background stone, leaving the figures raised slightly above the flat surface.
This specific technique held applied paint much better and caught the ambient light effectively in the shaded environment.
The colors they applied were not chosen merely for aesthetic appeal. They constituted a highly regulated visual language.
Blue, derived from a synthetic pigment called Egyptian blue frit, heavily symbolized the life-giving waters of the Nile and the expanse of the heavens.
Red, created from naturally occurring ochre, represented the harsh, chaotic vitality of the desert, which they referred to as the Desheret. Green was utilized to denote vegetation, health, and the concept of continuous rebirth.
The physical placement and alignment of these temples were also precisely calculated by the architects. They were aligned astronomically.
Many temples were oriented on an exact east-west axis to perfectly mirror the daily path of the sun.
The Great Temple of Amun-Re at Karnak, for instance, has its main axis strictly aligned with the sunset on the day of the summer solstice.
Other temples were aligned on a north-south axis for specific stellar associations, utilizing instruments like a gnomon, a vertical rod used to cast shadows, to measure the sun's position and ensure exact cardinal placement.
While Karnak was an accumulative, collaborative project built by dozens of pharaohs over centuries, one specific ruler constructed a standalone mortuary temple that completely abandoned the traditional enclosed mold.
We are looking at Hatshepsut's architectural masterpiece, Djeser Djeseru, which translates from the ancient Egyptian as Holy of Holies.
Hatshepsut's mortuary temple is located at the site of Deir el-Bahari, constructed between her 7th and 20th regnal years.
She was heavily influenced by the temple of Mentuhotep II, an 11th dynasty ruler, whose own mortuary temple sat immediately adjacent to her chosen site, built 6 centuries prior.
But Hatshepsut and her architect, Senenmut, radically altered the layout to suit her highly specific, unprecedented political needs.
Instead of a traditional closed, flat structure built on the plain, she constructed 3 massive, elevated, open terraces that rise directly into the sheer limestone cliffs of the Theban mountain.
These expansive wide terraces are connected by long, central, ascending ramps and are fronted by wide, shaded porticos featuring strict rows of geometric colonnades.
It is a profound integration of built, geometric form and the rugged natural landscape. The vertical columns visually echo the vertical striations of the limestone cliff face behind them.
But the internal arrangement of the specific cult spaces reveals her true priorities. In standard royal mortuary temples, the primary central axis of the building is reserved exclusively for the mortuary cult of the deceased pharaoh.
Hatshepsut deliberately displaced her own mortuary cult sanctuary to the southern side of the complex.
She gave the primary, central, elevated axis deep in the cliff to the sanctuary of the state god, Amun-Re.
She executed this specific layout to directly accommodate a major state religious event, the beautiful festival of the valley.
Every year, the sacred bark, a portable boat-shaped shrine carrying the cult statue of Amun-Re, was transported in a massive, highly visible procession from Karnak, ferried across the Nile, and carried directly up the central ramps of Hatshepsut's temple to rest temporarily in her sanctuary.
By physically aligning her temple with Karnak across the river and centering Amun-Re in her own monument, she intimately and visibly linked her own eternal mortuary cult with the preeminent god of the Egyptian empire.
On the middle terrace, she included specific, separate architectural shrines dedicated to the goddess Hathor and the god Anubis. But It is the specific carved reliefs on the porticos of this middle terrace that demand close analysis.
Right. When you evaluate the content of these carvings, the structure feels less like a traditional tomb for a deceased monarch and more like a carefully calculated permanent political billboard. Was she using the scale and the specific placement of these reliefs to justify her position as a female pharaoh in a traditionally male role?
That analysis is highly accurate. Hatshepsut's position as a female pharaoh, ruling in a traditionally strictly male role, was politically precarious. She lacked the traditional masculine markers of kingship.
Therefore, she utilized the monumental architecture and the extensive decorative program of Jesru as an aggressive instrument of political legitimization.
The southwest portico features highly detailed extensive reliefs of a massive, state-sponsored naval expedition to the land of Punt. The carvings show the Egyptian ships returning to Thebes heavily loaded with exotic, highly valuable goods.
Like live frankincense trees with their roots and baskets, raw ebony, gold, ivory, and exotic animals. She is utilizing the architecture to permanently display her immense economic power and the vast prosperity she successfully brought to Egypt during her reign.
And on the northwest portico, she pushes her legitimization a step further into the realm of theology. The reliefs carved here depict the complex narrative of her divine birth.
They visually illustrate the state god Amun-Re visiting her mother, Queen Ahmose.
Yeah.
The architecture is publicly implying that Amun-Re, not her mortal father Thutmose I, is Hatshepsut's true biological father.
She is using the sheer scale of this architecture and the specific, unavoidable placement of these narrative reliefs to publicly and permanently justify her divine right to rule over the population.
Undoubtedly. The architecture was her chosen medium for state propaganda. This strategy is further cemented on the uppermost terrace.
The portico on this level was fronted by 26 colossal Osiris statues of Hatshepsut herself, standing rigidly over 5 meters tall.
Crucially, the statue is positioned on the southern side of the terrace where the white crown, representing Upper Egypt. The statue is positioned on the northern side where the red crown, representing Lower Egypt.
Through the strict spatial geography of the statues themselves placed upon the architecture, she is claiming absolute, unquestionable dominion over a unified Egyptian state.
Hatshepsut highly manipulated traditional architectural forms to legitimize her unprecedented rule. However, a few generations later, another pharaoh would completely discard the traditional architectural vocabulary altogether to physically enforce a radical new religion.
We are assessing the reign of Akhenaten, often referred to as the heretic pharaoh. Akhenaten made the unprecedented decision to abandon the traditional polytheistic pantheon of gods, particularly targeting the immensely wealthy and politically powerful cult of Amun at Thebes.
He instituted the monotheistic, or at least henotheistic, worship of a single entity, the Aten, the physical sun disk. To match this massive theological revolution, he required a total architectural revolution.
He abandoned the ancient capital of Thebes entirely. He moved the center of the empire to a completely new, untouched site in the harsh desert, a city he called Akhetaten, known to us today as Amarna.
This specific period provides the first true, large-scale evidence of strict urban planning based on a completely new, centralized ideology.
To understand the shift, we must look at the function of traditional Egyptian temple architecture. As we analyzed at Karnak, traditional temples were designed around the concepts of mystery, shadow, and strict exclusion.
The deeper a person went into the temple complex, the darker, smaller, and more restricted the spaces became, ending in a pitch-black, windowless sanctuary containing a hidden statue.
The priests of Amun controlled access to this dark space, which granted them immense political leverage. Akhenaten flipped this architectural design inside out.
Because the Aten was not a hidden statue, but the literal, highly visible sun disk in the sky, there was no longer a need for hidden statues in dark, restricted rooms. The architecture of Amarna completely abandoned the heavy stone roofs and the dense hypostyle halls. The new temples dedicated to the Aten were built entirely open air.
They featured vast, expansive, unroofed solar patios. Instead of a single hidden altar reserved for a high priest, the great temple at Amarna contained hundreds of individual offering tables spread out evenly under the open sky.
This specific architectural layout allowed the direct rays of the sun to hit all the offerings simultaneously. It completely democratized access to the divine, effectively stripping the traditional priesthood of their exclusivity and their political power.
The entire city was laid out conceptually around the hieroglyph Akhet, which translates to the horizon. The urban layout featured exact, highly rigid geometric proportions based directly on the square width of the temples.
The central administrative zone included the Great Temple, the Small Temple, and a massive royal palace constructed primarily of mud brick.
The royal palace at Amarna was not merely a royal residence. It was a sprawling complex modulated strictly for economic efficiency and state control.
It contained specialized residential zones, extensive administrative service areas, massive state bakeries, and dedicated production areas, all integrated into a cohesive, highly regulated urban grid.
But there's a distinct, fatal irony in the architecture of Amarna. Because Akhenaten demanded his new capital be built almost instantly, the builders could not rely on the slow quarrying of massive, multi-ton blocks.
They utilized smaller, highly standardized stone blocks called talatat. A talatat block is small enough to be easily carried by a single worker.
The builders combined these small modular stones with vast amounts of rapidly laid mud brick directly on the untouched desert terrain.
Utilizing the talatat system was incredibly efficient for rapid, large-scale construction. It allowed an entire city to rise in a matter of years. But it also meant the architecture was inherently structurally fragile compared to the massive megaliths of Karnak or Giza.
Because they built so quickly, relying on these smaller modular blocks and highly vulnerable mud brick, it created a massive vulnerability. After Akhenaten died, the state and the populace violently rejected his new religion.
The subsequent pharaohs decided to erase his legacy. Because the buildings were made of small talatat blocks, they were easily dismantled by hand. Later rulers took the millions of talatat blocks, transported them back to Thebes, and used them merely as internal rubble fill for their own massive pylons at Karnak, completely erasing the city Amarna from the physical landscape.
Architecture is fundamentally and inextricably tied to ideology. The physical structures manifest the specific belief systems and power dynamics of the culture that builds them.
When the ideology of Amarna died with Akhenaten, the highly specific open-air architecture that supported it was immediately abandoned and destroyed.
The Egyptian state rapidly returned to the massive, enduring, heavily shadowed stone, post, and lintel traditions of Thebes to reestablish the traditional order.
We have analyzed an immense span of time, engineering, and human labor today. We began by examining the humble mud brick mastaba, composed of Nile silt and straw, constantly susceptible to the ravages of the annual floods.
We analyzed how Imhotep translated that form into stone, stacking mastabas to engineer the massive celestial stairway of the step pyramid.
We broke down the staggering logistical mathematics and the highly complex internal ramp mechanisms required to elevate the 2.5-ton blocks of Khufu's Great Pyramid.
We evaluated the dense, psychological, heavily shadowed forests of Karnak's hypostyle halls, where monumental stone columns mimic the primordial marsh.
And we explored how Hatshepsut utilized the soaring geometric terraces of Deir el-Bahari as a massive, permanent political billboard to enforce her authority.
Through all of these vast architectural variations, from solid, impenetrable mountain-like tombs to sprawling, open, sun-drenched courtyards, the central motivation of the builders remained constant.
The ancient Egyptians were highly organized. They utilized every natural resource, applied every newly discovered mathematical principle, and mobilized every ounce of human labor available to them to impose strict geometric order on a highly chaotic natural world, ensuring that their civilization and the spirits of their pharaohs would endure securely for eternity.
It is common to look at ancient Egyptian architecture. The endless stone tombs, the massive fortified mortuary temples, the highly elaborate subterranean mummification complexes, and assume they were a culture entirely obsessed with death.
But if you closely evaluate the specific choices of the architects, the integration of living plant motifs bursting from the capitals of the columns, the highly precise astronomical alignments designed specifically to capture the daily renewing rays of the rising sun, and the massive logistical infrastructure built into the tombs to ensure a spirit's ongoing daily sustenance with physical food and drink.
Perhaps the architecture provides a different conclusion entirely.
Exactly. Perhaps they were not obsessed with death at all. They were obsessed with engineering the permanence of life. Thank you for listening. History Maps. Learn history visually.